Welcome back, Structures of Math students. This is Mr. McKenna, and we're going to talk about chapters 5.1 and 5.2 today. This PowerPoint, like all our PowerPoints, is available for you to look through, peruse, skim through, advance, rewind, right there in eLearning Blackboard. Also, we're recording right now, and this video should be available on eLearning Blackboard shortly after our lesson today. If anyone has any questions while we're doing this video, please don't hesitate to enter them into the chat or to just unmute yourself and say out loud into the classroom your idea and we'll address it. I welcome that, and please don't feel like you're interrupting. And also please be kind and helpful to me and let me know if I can explain something a little better, or if I'm moving too fast. I have a tendency to do that and I don't mean that. And if I do that, I'm sorry. So just let me know. I'm happy to repeat things and to go back if we feel like we're going too fast with things. Okay, so today we're doing chapters 5.1 and 5.2, mental computation and computational estimation. So the first question is, what is 12 times 50? Now, I'm not going to ask you this question in efforts to get you to do the old school methodology of multiplying two-digit numbers by a two-digit number and so on. We're trying to find some trick here. And if I was in a classroom with you guys, I would have you all try to contribute, and I'm not going to require that of you here in this live online platform, but there are a lot of different ways to look at this. Some students will look at this like they know that 12 times 5 is 60, and you can just add a 0, so it's 600. There are students that will look at this and say, I know that 50 is not that different than 100, it's half of 100. So if I think about 1200 and then I cut that in half, it's 600. Some students will look at this and think about 10 times 50 plus 2 times 50, which is 500, plus 100, which is 600. And as you can see, there are a lot of different ways to figure this out using tricks. And that's what I need you guys to start thinking about, especially if you're going to be teaching in the classroom. These tricks, especially with math, are really key, and the teacher is supposed to have a solid grasp on this kind of material. So here are some great ways to represent the number, the product 12 times 50. In one case, you can see here, we've changed it into 12 times 5 times 10. In other words, we've changed that 50 into 5 times 10. And then we can apply our associative property and deliberately associate 5 times 10 first, figure that out, or rather 12 times 5, I'm sorry, 12 times 5 first, figure that out, right? And that's your 60. And now it's about 60 times 10, which is 600. Here's another way you could think about multiplying 12 times 50. And like I said, not everyone is going to think this way, but some students will think this way when they're trying to figure out products. 12 times 50, what if instead of it being 12, we call it 10 plus 2? This is the idea I was talking about earlier, where we take 10 50s and 2 50s. Imagine they were $50 bills. Maybe that will help as well. But if you did it that way, and you wind up applying the distributive property here, you'll distribute that 50 to each of the two numbers inside there. You wind up with two smaller products. You have 10 times 50, and you also have 2 times 50, and of course, they also add up to 600. One further way, what if instead we change 12 into 6 times 2 times 50, and then we apply the associative property again by changing where the parentheses are, and as you can see, I've moved them from 6 times 2 over to 2 times 50. And, 2 times 50 is easy to figure out. That's 100. So 6 times 100 is 600. So you just saw 6 great ways to answer a question like 12 times 50. And when you're trying to introduce this idea of mental computation, you should try to limit the questions that you're making up to the kids so that they work out nicely at first. It will encourage them to keep trying and to keep on doing the estimations. Of course, rather not estimations, the computations. Of course, this is supposed to be a tool set for the back of their mind when they're in a place where they're trying to figure out numbers quick. You want it to be fun for them. If it's a case where the numbers are deliberately very complicated up front, it may not work. That's why as teachers in elementary school, you have to learn how to pace the lessons and make it that the material you're delivering is in little pieces and is in digestible pieces. Whether you're in elementary school or college or any place that you're teaching, you have to be careful and think about how much can your students, how much are they capable of learning today? You don't want to overload them, and you want to give them things that are learnable, that are easy to navigate through. For example, 12 times 50 is a little bit challenging, but it's not, it could be very much worse than that. And that's what I mean. So be creative and clever with the way that you set up your activities when it comes to helping students with mental math. And remember, different students think mentally differently, you know. So now, here we have another great example, and we have what is 147 minus 66? And basically, for the rest of today's lesson, you'll see all kinds of interesting basic arithmetic questions like this, and all kinds of fun new techniques that you can apply to using them. To be honest, I regularly use these. I mean, I know part of it is because I'm a math teacher and math is a big part of my life, but very often in common life, when I'm shopping at Wawa, the things I do in my life, when it's time to subtract things, I go to some of these mental tactics that I've learned here. And I hope that you will too. So try to embrace it, my friends. Let's explore what it would be like to subtract these two things. I'm sure that most of you have an idea in your mind. I hope you can see that the answer will be 81 for this question. But since you know as a teacher and as the adult in the room that 81 is the answer, how about if you look at it in different ways and see if you can get to 81 in other ways? And doing that will put you in the shoes of your students, you know, and it'll make you help you to think like them and see what their thought process is and why they are thinking the way they are. It'll also tell you a little bit about who they are, and their personality comes out a little bit in it when they share how they've thought up answers, you know. So the first idea, of course, is really to just kind of do it in your head, but and that is not hard to do. But here are some alternative methods about how you could subtract those numbers. The question, by the way, I have put over here every time in our mental math slide so that we can keep on referring to what was the question again. This is the question: what is 147 minus 66? So what did we do here? Well, what we did was we took a number that we like, a number that we prefer. It could be any number you want. And we decided to add it to both the minuend and the subtrahend. And you're allowed to do that every single time. Why? Well, I'm going to give you a very crude example to make it really clear so that it's obvious, and you'll see what I write and you'll think, oh, obviously, of course it makes sense, you know. But let's take a common example of something that you definitely know for sure. Like, for example, something like 100 minus 70. And you know what the answer is to that. You know what the answer is. Let me just spotlight this. Here we go. Okay, you know what the answer is to this question. It's 30, obviously. You knew that already. But the point I'm trying to make is you're allowed to add anything you like to both of these numbers. So let's say, for example, it was 113 minus 83, where I added 13 to both numbers. Isn't it still 30? See that? If I wanted to, I could add anything I want to those two numbers. 5,000. Do I still get my 30? Okay. And likewise, while I'm at it, I could subtract anything I want from both numbers. I could have called this 99 minus 69, and it's still 30. So I could subtract anything I want from the minuend and the subtrahend. I can add anything I want to the minuend and the subtrahend. A lot of people don't know that and don't think about things like that. So if you're faced with a very uncomfortable question, like, for example, something that needs borrowing in some way, how about 159? No, 151 minus 113. The borrowing comes into play and it becomes a little tricky. You could do this and you could write it one on top of the other, or you could try to exceed the 3 a little bit, you know, in some way. Maybe make it that you add 9 to both of them. If you add 9 to both of these numbers, you get 160 minus 122. Might be a little easier to figure that one out. But either way, you know, adding a number to both the minuend and subtrahend, or subtracting a number to both the minuend and the subtrahend, it can help. And sometimes it doesn't help, sometimes it does. So let's look again at this mental math case where we have a student who's choosing to add 4 to both the minuend and subtrahend. And look what happens when you do that. You wind up with 2 new numbers, a new minuend of 151 and a new subtrahend of 70. Perhaps the reason why they added that way is to get the second number to be a nice round number that has a 0 at the end. In a case like this, maybe I would have chosen to add 7 to both of them. Let's see what that looks like for a minute. What if instead I took this number and I added this subtraction case and I added 7 to each of them. That might be a little more practical. Let's see what that looks like. 158 minus 120, that's clearly 38. Look how quick and easy that came out. So this is what we mean by mental math. If you can figure out the key, then you can unlock the door. You know, it's a little puzzle, and if you know how to figure out the puzzle, you got the answer. This is a challenging question. If you throw this out in a room of 10 people, everyone's going to like roll their eyes, and someone will come up with it in a little while. But if you're smart about it, and you take that second one and turn it into something with a 0 at the end, add 7 to both of them, 38 does come very quickly. And I need you guys to be really sharp teachers that way, so that when you enter the classroom, the kids have a really great, you know, they can go right to you and ask you quick, and you have that wisdom, and there's respect that comes from that as well, you know, as the teacher. So I hope that helps you a little bit. I really do like all these mental math techniques. To me, I think they're wonderful because here we're, for the first time, really analyzing them. You don't do this in pre-calc. You don't do this in college algebra. In fact, I don't remember doing this with any of my high school students when I taught high school math either. And I think that we should. This is a very great technique here. Now, another way you could have done this here is, if you look, they have 151 minus 50 minus 20 minus 81. Meaning, oh, maybe 151 minus 70, that takes a little bit of thought, you know, because there's a borrowing involved in that. So 151 minus 70, if you make it instead 151 minus, let's turn 70 into two numbers that are easier to chew up and digest. How about 50 plus 20? Because if I first subtract 50, I'm at 101. And then when I take 101 minus 20, I think I can figure that 81. And again, not every student is going to think that way. Some students will actually go through the hard work of thinking, what is 15 minus 7? It's 8. And you could do that too. And some students have that number fact already stored away in their head, and that's not hard for them to do. But we're going to see some students who think in this way too, and we have to encourage them and say, that's great. Keep thinking that way, because if you can get it that way, you'll always get it that way. The worst thing you could do is say, oh, no, no, no. You shouldn't be doing it that way. That is the worst thing you could do to a child, especially if they're finally starting to see a way to get answers with arithmetic. I hope that you will be encouraging our children. I know that you guys want to be good teachers. That's the trick to it. You have to make sure that you are open-minded to what they're thinking and how they learn. This is a great way to change the way you think a little bit about what a classroom is, about what teaching is, about what learning is. We're actually giving the children the tools that they need to figure it out on their own. And then we can kind of guide them and ascertain whether they got it right or not, or whether they're thinking correctly or not, and repair any thinking that might be a little bit off. And then they'll leave your classroom with this amazing wealth of knowledge of how to answer tricky questions before everyone else. Where did I learn that? I learned that in Mr. Marquetta's class. It's such an extreme honor to hear that as a teacher. Is that, oh, well, I had Mr. Marquetta, so I know how to do factoring when I get to college algebra. Like, that's the idea. Try to make it that you bring across as much as you can that way, my friends, and that's what good teaching is. Okay, so here's the same case. Actually, no, this is not the same case. I'm sorry, this is a different case, right? Is this a different case? No, this is the same case. Okay, in this case, what's happening is we're taking these numbers and we're messing around with them a little bit more. First, we're going to take the number 66 and add 4 to it. And then we're going to take the number 70 and we're going to get 70, okay? So we take 66 and we add 4 and we get 70. Then we take 70 and we add 30, we get to 100. Then we take 100 and we add 40, we get to 140. And then we take 40 and we add 7 more and we get to 147. So the first two lines of this arithmetic you're looking at is a student climbing a ladder from 66 to 147. And each time they climb the ladder, they add something that's easy to digest, like 4, like 30, like 40, and then like 7 to get to the end. So they kind of got to the nearest 10, then added until they got to the nearest 100, then added until they got to the next part, and the next part was just add 7 on again. And then if you see, they tried to put those things they added in parentheses so that they stand out. 4 and 30 and 40 and 7 add up to 81. So here you have another great example of how you could do subtraction in your head. And sometimes this is just the way to do it. If you have a large amount of money, and I've heard this before, like for example, if you have a lot of cash, or if you have a checking account that's very high in a balance right now because you're about to pay tuition, or something in a case where you're about to pay a large amount of money, it may go through your mind to think about how much you're trying to pay and how much you have. Say you have $4,200, like you have $4,215, and the thing is $3,970. You could go down to 15, you could go down to 4,200, you could go down 200 to 4,000, and you could do this. And you'd be able to count and kind of get the answer. It may be a little bit more practical and easy for you to do it in your mind and kind of jump from one stepping stone to the next, from 66 to 70 to 100 to 140 and then to 147. Those little jumps are just little numbers that add up easier. 4 plus 30 plus 40 plus 7 is not very hard to figure out. And we get our 81. So now for subtraction, let's think about the question 140 minus 60 first. In other words, we're not thinking about the ones place. We're ignoring the 7 and we're ignoring the 6. So we just do the hundreds positions first. We say, okay, we're gonna do 140 minus 60. And later on, I'm gonna do 7 minus 6. Now in this world, it's not that hard to do because 7 minus 6 is not a negative number, but it could have even turned out that the first number was smaller, like it could have been 146 minus 67. This still would hold because if you start with the actual tens places, which is 140 and 60, you wind up with 80 there. And you could take the 80 and go from there. It's now 80 plus that 7 minus that 6, which ultimately is 80 plus 1, which is 81. But the point I'm trying to make is you could have done 80 minus something and then plus something, or in other words, it's possible that when you get to this position, you go down below 80. Say, for example, if it was 141 minus 69, you'd get your 80, and then you get plus 1 and minus 9, which turns out to be 72 ultimately. So you can do this, and sometimes when you do it, the ones places make you decrease the number instead of increase the number. That's the point I'm trying to make. Okay, so now let's talk about this one where we have 25 times 24. You may not necessarily see it right off the bat, but I can tell the number is 600. The reason why I know this number is 600 is because I'm thinking about how 25 is a quarter of 100. And whenever I see 25 times something, I think about how that's like multiplying it by 100 and dividing it by 4. To me, 2400 divided by 4 equals 600 is the easiest way to go. Some students instead are going to think about this like it's 10 plus 10 plus 5. So 240 plus 240 plus 120. Or you could think about it in a whole bunch of other ways as well. Let's see what your textbook says. Oh, it looks like they haven't. Yeah, they didn't talk about it. So I'm going to talk about this one. Okay, that's the kind of reference. Let's look at 25 times 24. Let's see how many different ideas we can come up with in mental math to get the answer to that. Let's start by at least knowing for sure what the actual answer is. And if you're not 200% sure of that, go and get a calculator and just double check it. And that's not a bad thing to do because we want you to be really solid on these, that when you are helping the kids, you really understand what you're talking about, okay? So first and foremost, let's just establish the answer is 600 certainly to this question, okay? Now, how can I get there? What can I do to get to 600? Okay, here's one idea. One idea is rewrite 25 to be 1/4 times 100. And then apply your favorite property, the associative property, like this. And now you have 1/4 of 2400, which is not hard. That's 600. That is one way you could do it. Another way you might want to think about doing it is taking this 25 and splitting it up. So if you take the 25 and split it up, it would look something like this. That's my coffee pot. Okay, 25 times 24. Let's change 25 times 24 into 10 plus 10 plus 5 times 24. Is that not the same? Of course it is. The distributive property, because this is times, means you got 240 plus 240. And then 5 times 24 is another thing to think about. What's 5 times 24? 5 times 24 is the same as 10 times 24. times a half. You could do it that way or look at it this way, 1/2 times 10, because that is 5. And now, ignore the half for a minute. What is 10 times 24? What's half of 240? 120. Either way you look at it, you still get your 600. Are there other ways that we could do this? Well, of course there are. Let's take the same question and split it up amongst the 24. How about if it was 25 times 20 plus 4? Distributive property, 25 times 20 plus 25 times 4. This is the easiest part. We all know that's 100 over there. This, you might as well do something with the 10 and 10 again if you want, but anyway you look at it, 500 is what goes there. Okay, and your answer is 600. Okay, so just as a reminder, my friends, this stuff is, you know, mental math, and you're not supposed to be doing this with any of the methods that you've learned, you know, the multiplying a 2-digit times a 2-digit. For example, you might remember learning when you did a question like this, you know, of course, to go like this, 25 times 24 and multiply and start going like this. I mean, you know, this is not a really bad thing to do, but this is not what our lesson is about, you know. This is arithmetic. We're not learning about this today. I know you know how to do this. I need you to learn about how to do this kind of stuff where you're using the properties and different devices to split them up. So I do recommend that you take a minute and do it this way, or use a calculator, or do lattice, or do something to get the answer like this. But remember, you're going to need to show a way to do 25 times 24 that's different than that as well, using mental math. That's what this is. This is mental math, okay? Let's keep on looking at our other questions here. We have a lot of good questions here today. Here's another good one. 6 times 43 plus 6 times 7. 6 times 43 is a pretty yucky thing. It's going to be an ugly 2-digit by 2-digit thing that's going to be kind of cumbersome. So what we're going to do is, once again, we're going to see if we can figure out some kind of little trick to get the answer to this. So let me jot down the question, then we'll look at it together. And, you know, you could just go there. You could just figure out what 6 times 43. 6 times 7 is not that hard. 6 times 7, we know that to be 42 from our times tables. But what they're hoping you'll do is some kind of trick. Now, you may not necessarily see it right off the bat, but if you stare at it for a minute or so, it may come clear to you that this is an example of the distributive property. If it helps you, you can employ parentheses here, like this, and maybe then it becomes a little bit more clear that both of these cases have the same multiplier of 6. So you could show this as a distributive case. What if you do it as 6 times 43 plus 7? Why would you do that? Well, in this particular case, 43 plus 7 is a nice round 50, but it doesn't always work that way. Sometimes it doesn't work that way, and if it doesn't work that way, maybe you shouldn't be going with a backwards distributive property case like I did here. You know, it's going to depend on what the best approach is. In this situation, because 43 and 7 are such a nice pair that they become 50 quick and easy, the key to the locked door here, my friends, is use a distributive property. And you can see we do wind up with a very simple case after all, and we do have 300 as our solution. Are there other ways to do this? Of course there are, but if you look again at this question, I'm going to ask you to try to remember this model. If you look again at this question, it really is, you know, pretty specifically made up to work out this way. And when you're doing something like this, I would have you, I would recommend as a teacher that you would do a whole bunch of cases like this where you could do 19 times 28 plus 19 times 72, such that the numbers add up to 100 or something simple that way, so that you could get a nice multiplier of 50 in there, and the kids feel a sense of accomplishment. And what happens is they are learning the distributive property in a very big way. And that feeling of this isn't too hard and the numbers are nice and whole, especially with the younger children, is really key to helping them understand and gain a good number sense, you know. So Here's what we're going to do right now. We're going to work on this. This is numbers 1 through 10, and we're going to take a little break. This is an activity that is in your textbook, and I'm going to ask you in class to work on this activity. There's 10 questions here, and when we return from our break, I'm going to go through great ways to do all of these questions, and we'll discuss them and think about different alternative methods. And if anyone has any fun methods, please feel free to jump out and say them as well. But we are going to take a little break, and during our break, you're not required to do them, but I recommend you kind of look at them a little bit while you're sipping your coffee and hanging out. Right now, my friends, it's 8:35. I'm going to ask you to please return at 8:50, and if you can return at 8:50, we'll come back and we'll do these questions together. And in the meanwhile, I'm going to ask that you work on those questions. We still haven't taken attendance, so please stick around if you don't leave yet. We still do need to take attendance, and that will happen when we return from break. Okay, guys, so we are now officially on our 15-minute break, and we will return back to class at 8:50. Okay, so we are returning from break now, and we're all taking a look at activity 2 here. And during the break, we might have looked at a couple of these questions, try to come up with some ideas. Let's see if we can figure out number 1 and see what some great practical approaches are for number 1. Number 1, we have 50 times 35 times 2 times divided by, and I'm going to really exaggerate that divided by anyway, 5, because we're going to talk about that for me today. Okay. So looking at this arithmetic example, it may seem that these are together and this one is out of it, because we're all multiplying here, and then 5 is divided by. But you might recall that when we've studied in the past multiplying and dividing fractions, that dividing by a number is the same as multiplying by its reciprocal. I need you to believe that. If you can believe that and kind of invest in that, then the rest of this is going to be easy. Let's think for a minute about the idea of 1/3 divided by 3/3, 3/5 or something like that. How do you do this question? Well, you take this right here, which is a quantity of its own, and change it completely to this. And you believe that the same thing is happening. In other words, division and multiplication really are the same thing, just kind of spoken in a different way, or kind of with a different grammar and punctuation. They are the same thing. They're connecting one quantity with another quantity. If you want to change the operation, it's just another version of that quantity. So ultimately, they kind of are the same thing, which means that you could have your students think about these numbers in this way. That's one of the numbers. That's a pair. That's a pair. But what I'm saying is to keep the sign in front. So this is an idea. Times by 2. This is an idea. Times by 35. This is an idea. And since they all are the same, multiplication and division, you can switch them around if you want. So let's switch them around. Wouldn't it be easier to think about 50 times 2 and 35 divided by 5? You could switch them around to that extent, or some students will just switch these, You could just switch those and get away with it, and then not consider the idea that divided by 5 is the same, and then do this. And there's your 700, right? But if instead you move this over, you could do things like that as well. You could move the 5 all the way to over here and then add to the next one, like this. With 50 times 35 times 2 divided by 5, what if we drag this over here? Because guess what? Some of your students will. It would look like this. 50 divided by 5 times 35 times 2. This is 10. This is 70, and guess what you get? Another great example of mental math. So what we're trying to say is this can be done in many ways. Each of these has many different ways to do. Take a look at that next one, 19 times 21. How can we figure that one out? 19 times 21. Well, one way to figure it out is like this, 19 times 20 plus 1. I'm sure a lot of you were probably thinking that, right? And if you think of it that way, you can now use your distributive property, or you could split it up even further like this. 10 plus 10 plus 1, right? And why would you do it that way? You do it that way because 19 times 10 is very easy. 19 times 1 is very easy. It's 190 plus 190 plus 19. Okay. So again, we have some great examples of mental math here. In this case, we're applying the distributive property. There are alternatives where you change this into 20 minus 1, make this 20 plus 1, and you get another fun little example that boils down to 399. But again, it's different people think in different ways. You know. Let's look at the third one. 171 minus 58. For this one, I think you might recall, when we have a subtraction, you can add anything you like to both the minuend and subtrahend. So let's do that. Let's get this to be up to 60. I'm going to add 2 to both of them. 173 minus 60. Much easier to think about, right? Oh, no. Sorry, 113, right? Yeah, 113. Right? There are other ways to do that. You could do that in this way. 171 minus 58, some students, is going to be 58 plus 2 is 60, right? 60 plus 40 is 100. I hope you're following me with this, okay? 100 plus 70 is 170. And last, of course, 170 plus 1 is 171. Remember that model? Because we went through that too as one of our mental math cases. And what happens is you take each of these, let's use a different color for fun. Keep it fun in the classroom, guys. Keep it fun in that classroom, right? We're going to take these numbers and add them up. By the way, not really hard to add them up. 113 is what it is. You can see it. Okay. You might not like this way. You might not like this way. You might like this way better. Remember, it doesn't matter what you like, you're the teacher. You have to show all the ways. That's what a good teacher would do. You could tell the students, I prefer this way instead of that. I think it's easier to do it this way, but remember to remind your students it's okay any way you think. You have to be able to be open enough to see how they think too. 171 minus 58. Our next case, 3476 plus 2456 minus 1476. Ugh, goodness, that one's pretty heavy. How would we go about figuring this one out? Let's see. Well, there's a couple things we could do. We could start by trying to just focus on this piece alone and get an easy answer for that. And then after we get that piece, then carry on with the next one. We might want to instead start with these two and figure out what that is. And when we're done, then focus on the first number. It's up to you what you do first. It doesn't make a difference. But whatever you do, try to use some kind of mnemonic device or some kind of memory or mental math kind of thing where you're not actually adding them. You are including and involving some kind of interesting alternative way of counting that the kids can relate to. Maybe what I'll do for this one is I'll try to get to some easier numbers. Like, let's see. Maybe I'll focus on the first two then, okay? And if I'm going to add those two up, I think I should focus on the second two. So let's work on these then. Okay, and again, everybody's gonna think about this differently. What if we take these and we do the counting method again like we did last time? Where we take this number and we try to count up to get to this number. So I have 1476 plus 24. It's going to be 1500. 1500 plus 500 ought to give you 2000. 2000 plus, and the next number I'm thinking about is 400. And then how about 2400 plus 56 equals 2456. Right, so once again, these numbers get added up together. Looks like 980. Okay, so if that's 980, what can I do with that 980? So I can rewrite it and have a new puzzle. 3476 plus 980. For this one, I'm going to use another technique. I'm going to think about estimation and rounding for a minute. And I'm going to take this number and exaggerate it to my liking to make it easier to think about. It's the same as 1,000 minus 20, this number. So what if I do 3476 plus 1,000 minus 20? You can put this in parentheses if you want to represent the 980, but the associative property allows that you can get rid of them anyway. You got 4476 is what these guys make. 4456. Next, we have 50 times 340. Lots of fun with this one. Of course, 50 is half of 100, so I would go right in with that 1/2 times 100 times 340. And then 100 times 340 is 3,400. No, 34,000. And see, there's hidden lessons in this. Like, remember, kids, back in October when we learned about counting zeros to have a new product because there's 3 zeros and all that stuff. So you could go back and revisit old fun lessons. And then here you have 17,000. All right. Now I'm going to leave the others. Let's see, 6, 7, 8, 9, 10. Right. Let's finish these up. Number 6. You're looking at 24 times 38 plus 24 times 12. A very clear example of your distributive property. If it helps you, use parentheses to show, like so. And then we do have a repeating multiplier of 24 here. So it is factoring ultimately. This is called GCF factoring, but you're doing it with numbers, not algebraic expressions. It's 38 plus 12. And how lucky we are that 38 plus 12 is a very simple sum, 50, right? 24 times 50, and then we can get creative with 50, or we can get creative with 24. Let's get creative with 24 this time, just to show an alternative example. What if we make 24 20 plus 4? And then the child will think 10 plus 10 plus 4, you know? You have to learn how to switch back and forth about the way different kids think and be okay with the way they write when it's different than the last kid's one. It's hard to do in math. It's one of those skills you have to try to get to, you know, and exploring these alternative ways, even when you feel like the better way is one way and a different way, if you do it, it does continue to help you build your understanding of how those kids think and then you can help them learn better, you know. You got 500 plus 500 plus 200 there. It's 1,200. Right. Number 7, 8 times 32 times 4. And you know, you got a little bit. It's a little crazy here, but one thing that you do have is, you may not know this, but these are all powers of 2, and I don't think we discussed that very much in any of the examples. But I would show my students yet another fun, exciting, different way to look at multiplication. If you notice that they're all in the same power table, we could talk about power tables. That's another thing. But the point is, everything here you're looking at is a power of 2. This is 2 times 2 times 2. This right here is 2 times 2 times 2 times 5, you know, 5 factors of 2. And then of course 4 is 2 times 2. I think I ran out of room there, but you see it. This is the 8, this is the 34, and this is the 32 rather, and this is the 4. You have 3 of them here. Oops. 5 of them here, and 2 of them here. The answer is 2 to the 10th. And you could have your students do a little counting game. What is 2 times 2? What is it times 2 again? What is it times 2 again? And again. And just keep it up and see if they can make it. And make a joke of it and have fun with it, you know, and let the kids laugh about it and try to make it exciting. It's hard to do, but you could do it. Okay, and keep on going until we get to 2 to the 10th. Times 2 again, 128. Times 2 again, 256. Times 2 again, 512. Times 2 again. I think, wait a minute, 2, 4, 3, 4, 5, 6, 7, 8, 9. Here we go. 1024. 1024, you might have heard that number before when you were buying an iPhone. Go and Google that. Okay, so I hope that makes sense, my friends. That's one example of how to do it with powers. Don't worry, I'm not going to hold you to that. It's not in your textbook, but it is another great way to show students and have them think in a different way. Remember, you're wanting to open their minds up and let them think about quantities, numbers, and things like that. That's our whole idea. And the next one is 245 minus 147. For this one, I'm going to do that thing that we do where we kind of add to both the minuend and subtrahend to make it an easier question. It would be easier if this was 150 here. So let's add 3 to everything. 248 minus 150. What do you get? Well, you're also kind of, once again, making it a little bit hard on yourself here. So let's make it easy once again. How about if I add 50 to both of them? It's now 200 here, and it's 298 here. It was easy. Now see how adding and adding again, it also brought a little bit of satisfaction, to be honest, that I got there and that it worked out so nicely and that I got an answer to a tricky question really easy and quick. That's the point of it. 98 this time. 0.36 times 25. And 25, in this one, if you start thinking about the relationship between decimals and fractions, a nice trick appears. For example, if you know that, if you say, okay, class, what do you say this number as out loud? And some of your kids are going to say 0.36. And you say, no. Remember, there was a word, we said it was 36 what? Right? 36 hundredths. Okay. Now, 25. 25 is the same as 100 divided by 4. Look at how quick and easy we got an answer. What's the answer? It's 9. You might be able to see already right now that it's 9. A little bit blurry there. Let me refocus. There we go. Okay, so like, why did we get 9? Well, because the hundreds cancel out, and the question becomes, what's 36 divided by 4? Right, you get 9. So this is a reason to give the kids incentive to think outside the box, to look at numbers in a different way, to dare to go down a path that they might not have before. What's the name of this number? 36 hundredths. Look how it connects to 25 this way. And our last one is 11.89 plus 6.55 plus 6.12 plus 13.24 plus 5.99. Notice this is a sum. These are all being added. And if they're all being added, then maybe I can find some kind of trick and do things to get things quick. Let's see here. Let's see if we can bring them to a nice whole number and then get their decimal connections out. For example, I'm going to call this, instead of calling it 11.89, I'm going to call it 12 minus 0.11. Maybe this one up here, 6.55, I'll call it 6 plus 0.55. 6.12, I can call 6 plus 0.12. 13.24, 13 plus 0.24. And for this one, 5.99, maybe I'll call it 6 plus, no, 6 minus 0.01. Now, you can get creative with, I want this to be a plus and this to be, this should have been 11 plus 89, or this could be 7 minus 0.45. Like you can make them anything you want, you know? And if you do that, then what happens is you have a little bit of a new thing going on here where you might be able to get away with some easy things here. And they design them, the textbooks and the publishers, so that there are tricks that show up in this when you do this. So if you can encourage the kids to do this kind of nearest whole number technique, you know, then you can get some new discoveries coming out of numbers here. For example, you might notice looking at it right now that this one plus this one plus this one will cancel out. They will cancel out. And if you're trying to figure out what this is, that's not hard because there's no carrying. You can do that in your head. See that? These numbers here, you could come up with a new technique to get those, or you could just add them at this point because you have done a mental math approach here. It's just important that you show something in the mental math. It doesn't have to be that every single thing you do is mental math. Like maybe we'll just, okay, for this one, guys, we'll let you add it up. What is it? 12 and 6 is 18, 24, 37, and 43. So it's 43. If that's 43 and this is 79, you got 43.79. So, okay, I hope that helps. And now you have some really great concrete examples of how to do mental math. I just want to give a couple of little closing remarks before we dismiss our class. First, my friends, give me a chance to take attendance. I still have to take attendance, and I will after we talk. It's 9:11. We will be dismissing in just a few minutes. But while I still have your attention, I do have some important announcements. I have some good news. Your exam that has been graded, there's going to be an adjustment made today. Everyone's going to get a bonus 4 points on it. The reason why is because there was one question that was faulty that one of the students brought to my attention. I removed it so that everybody could have a fair grade. As a result, everybody has only 19 questions and everyone could get a maximum grade of 96. So I'm adding 4 points to everyone for that one question. Basically, there was an error in the questions, everybody got the points for it. So you can expect that if you look right now, the number you have right now, it will be changed by the end of the day, and it will have 4 more points than it had earlier today because we're going to curve everybody with 4 points. The other thing that's important I want to mention is in today's PowerPoint, which you see here, I did make it as far as the end of chapter 5.1, which is estimation. The next chapter 5.2 where we start, which was mental math. The next one, which is 5.2 where we're doing estimation, you know, we're going to do that when we get together on Thursday. So when you do your web assigned homework, my friends, you'll get to questions about estimation that we haven't gone over in class yet. Just have patience and wait until we go through that lecture. Or if you're watching this after the fact, make sure you watch the second video before you try to do that next web assignment that's associated with chapter 5. Okay, I hope that that's clear. You could begin it, but remember, we've only gone as far as mental math. We haven't done the estimation questions yet. All right. So those 2 announcements being said, before we close our class, just want to say if there are any questions, now is a good time to ask them. I'm going to stop our recording.